All right, moving on down out of the mountains, you'll get to the Piedmont. The Piedmont literally just translates to foothill, and it's basically that like hilly, still relatively high elevation, just not as high as the mountain part of our states that's next to the mountains. So essentially, the Piedmont is just a remnant of several ancient mountain chains that have been eroded so far down that you really can't even tell they're mountains, or they used to be mountains. Okay. So it often looks like this, where there is bare rock exposed, not a lot of sediment deposition, but all around relatively flat. Right, so the mountains have already been eroded here. The Blue Ridge Mountains were originally formed by massive forces that caused what's now North America and now Africa to collide. And that collision stopped about 250 million years ago. So we talked about how the North Georgia Mountains were formed. But not only did this pressure, this convergence form mountains, it also created an immense amount of pressure and heat. And when that pressure and heat lifted up the mountains, it also caused the surrounding rocks and the deeper rocks to start melting. So the uplift, folding, and faulting of the mountain building activities exposed these ancient metamorphosed Blue Ridge rocks, which are the core of the mountain range. And the inner Piedmont, that's really close to the Blue Ridge, really close to the mountains, is really highly metamorphosed because of this. All right, most of the rock outcrops found throughout Black Rock Mountain, which is just one mountain in the Piedmont, are made up of biotite gneiss, which is a metamorphic rock that underlies a large portion of the Georgia Blue Ridge Mountains. So if you take a look at those rocks, it might look something like this. I know most of you are familiar with Stone Mountain, but it is in a series of mountains, also includes Arabia Mountain and Panola Mountain. We're going to talk about Panola. Panola is a 100-acre granite outcrop, very similar to Stone Mountain, but it's just smaller and more pristine, which is why we're going to talk about it here. It is, just like Stone Mountain, a granite batholith. Remember, a batholith is just an incredibly large frozen magma chamber that has been exposed on Earth's surface. It formed about 320 million years ago, so the same time that Appalachian Mountains were forming. And the dominant bedrock is here we go, biotite, aligioclase, quartz, microcline granodiorite. So a lot of minerals you should recognize in that long list. And it contains pods of amphibolic gneiss. So just gneiss that contains amphiboles, particularly at a low elevation. And so if you look at our metamorphic grade chart, you can see that amphiboles are very common of intermediate grade metamorphic rocks. So this is showing us that we got, the Appalachian Mountains got to the intermediate to slightly high grade metamorphism as they were building.